Welcome back to the LLM Wiki. This is episode 6, and with it we reach the fourth and final pillar of the series, Constrain. We have spent 5 episodes treating the wiki as something to read from. Retrieve the right pages, compile them well, verify their logic. But the most surprising finding in this whole research program is that a maintained wiki can do something else entirely. It can act as a safety oracle for a learning agent. Not a place you look things up, but a living set of constraints that keeps a deployed policy from doing something dangerous and that updates the moment the guidelines change, without retraining anything. This is the living constraint oracle. Let us build it up from the problem it solves. So start with the problem. Offline reinforcement learning trains a policy on a fixed dataset of past decisions, and in the domains that matter most, that constraint is not optional. You cannot explore insulin dosing strategies on real patients. You cannot try a risky shutdown on a live treatment plant just to see what happens. You learn only from history. But here is the trap hiding in that history. The dangerous actions are rare in the data precisely because careful human operators always avoided them. So the very behaviors you most need the policy to refuse are the ones it has almost never seen punished. The data is quiet exactly where it most needs to shout. That silence is the missing signal in safe offline reinforcement learning. How do people patch that silence today? 2 ways, and both fall short. The first is to hard-code the safety limits as fixed numbers, never exceed this insulin rate, always keep this concentration above that threshold. Clean and auditable, but frozen. The day a clinical guideline changes, your numbers are wrong and nobody notices. The second is to fetch the guidelines at query time with retrieval, with RAG. That keeps things current, but there is no systematic maintenance, no contradiction checking, no version history, no record of which rule came from where. Neither option treats the constraints as what they actually are, a managed, evolving asset that deserves the same care as any other piece of critical knowledge. And that is the opening. Clinical and operational guidelines are exactly the kind of knowledge that rewards compile time work. They arrive as long narrative documents, full of hedges and buried conditionals, hard to query reliably in the moment. So compile them, once, into a structured wiki, explicit evidence scores, contradiction flags, version history. Now you have a principled place to extract executable constraints from at training time, and, crucially, a place to push revisions through later, without retraining the policy. That is the living constraint oracle. The wiki stops being a reference you read and becomes an oracle the learning system consults about what it is forbidden to do. Same artifact, an entirely new job. Here is the machinery that turns wiki pages into constraints, we call it the wiki-to-constraint pipeline. Walk it page by page. For each page, the model extracts candidate constraints, the do's and don'ts buried in the prose. Each candidate gets a weight, alpha. An alpha is built from 2 things, how strong the evidence on that page is, multiplied by whether the candidate contradicts anything already accepted. If it conflicts, its weight goes to 0 and it is dropped. If it survives, we attempt the hardest step of all, try compile. We try to turn the natural language rule into an actual executable check, a function that can look at a state and an action and say, this is allowed, or this is forbidden. Extract, wait, compile. That last step is where the difficulty lies. And the difficulty is brutal, in a way that surprised us. Of all the constraints we extracted from the ADA diabetes guidelines, only 1.3% could be turned into a step-level executable check. For mental health crisis intervention it was 18%, those psychiatric rating scales have more operable structure. For therapeutic dialogue, about 12%. The gap between narrative guidance and a runnable safety rule is far wider than intuition suggests. Most clinical wisdom simply resists being compiled into a hard if-then. But do not despair at 1.3%. That fraction was taken from 1,907 extracted constraints, so even 1.3% still yields 25 real, hard safety checks. A small executable core, but a genuine one. Now, what do you do with those compiled checks once you have them? You fold them straight into the training objective. Our framework, wiki-to-constraint IQL, takes the standard implicit Q-learning loss and adds one term, a penalty, summed over every constraint, that fires when the policy proposes a forbidden action. Each penalty is scaled by that constraint's weight alpha, so high-confidence rules push harder than weak ones. And here is the elegant part. This requires no architectural change whatsoever. The constraints enter solely through the reward signal. Which means this is not really an IQL trick at all, it works for any offline reinforcement learning algorithm that optimizes a reward. The constraints are a layer you bolt on, not a redesign you commit to. Does it actually make the policies safer? Across three very different domains, yes. In type 1 diabetes, the rate of dangerously high insulin suggestions dropped from 98.6% in the unconstrained policy to 81.3%, a fall of 17.3 percentage points. In mental health crisis handling, the false alarm rate fell from 36.5% to 10.8%, down nearly 26 points. And in therapeutic dialogue, the balanced quality score nudged upward, from 0.88 to 0.90. Different metrics, different domains, but the same direction every time. Compiling guidelines into weighted constraints and penalizing their violation makes the learned policy measurably more cautious where caution is warranted. But the safety gain is not even the most important part. This is Guidelines Change, a new edition of the Diabetes Standards, a revised crisis protocol. In the old world, that means retraining your policy, which is slow, expensive, and risky. The living constraint oracle breaks that dependency. When a guideline is revised, you update the wiki. The wiki-to-constraint pipeline re-extracts the constraint set. The new weights flow into evaluation, and the policy parameters are never touched. We call this dynamic constraint update. Human expertise evolves on one side, the deployed policy adjusts on the other, and the wiki is the living bridge between them. The guideline moves, and the agent's behavior moves with it, with no retraining at all. How much does that update actually move the needle? We measured it as an amplification factor, how much wider the safety gap grows between the constrained and unconstrained policies after a guideline update, with no retraining. In the diabetes and mental health domains, that gap widened by a factor of 7.6. In therapeutic dialogue, by 2.3. Be careful how you read that number, though, it is not an absolute safety improvement. It is the leverage of the update mechanism. When the revised guideline says be more conservative here, the higher weights make the policy more conservative exactly there, and the gap between it and an unconstrained agent stretches accordingly. 2.3 to 7.6 times more separation, bought with a wiki edit instead of a training run. Step back and notice what kind of object the wiki has become. For 5 episodes it was a knowledge store, something you compile, lint, and query. Here it is something qualitatively different, a principled, maintainable interface between human expertise that keeps evolving and an autonomous policy that has already been deployed. That is a role the original wiki proposal never imagined. The clinician updates a guideline page. The agent in the field grows more careful. Nothing in between needs a data science team or a retraining cycle. The wiki is where slow, careful, human knowledge meets fast, automated decision-making, and the dynamic constraint update is the channel that lets one steer the other, safely, in real time. And with that, the spine of this series is complete. Retrieve, we learned why compiled memory beats reconstructing knowledge on every query. Compile, we walked the lifecycle that keeps that memory from rotting. Ingest, lint, drift, provenance. Verify, we made formal logic a first-class citizen, so the system can prove a contradiction instead of merely sensing one. And now constrain, the wiki as a living oracle that keeps a learning agent inside the bounds of current expertise. 4 pillars. Retrieve, compile, verify, constrain. Each one began as a single line in Karpathy's sketch, and each one turned out to hide a real research problem worth an episode of its own. Now the honest accounting, because this series does not sell. The executable core is tiny, remember, only 1.3% of those diabetes constraints compiled into hard checks. The rest still live as natural language the model must interpret. And the safety numbers, while they move in the right direction, are not a finished promise. Even constrained, the diabetes policy's dangerous suggestion rate stays high in absolute terms. Every result here came from small to medium benchmarks, several of them semi-synthetic. The amplification factors describe leverage, not a guarantee of safety. The living constraint oracle is a genuinely new and useful idea, but it is an early one. Treat it as a direction that works in the small, not a system you would yet trust with a real patient. So where does that leave us? With 4 pillars standing, and with a stack of honest cracks running through every one of them. The router degraded on its own feedback. The contradiction detector cried wolf. The executable fraction was tiny. And almost everything was tested only in the small. So the next 2 episodes turn that honesty into the main subject. Episode 7 asks the hard question directly: where does this whole pattern break? The personal knowledge base ceiling, multi-agent conflict, the limits of autonomy. We have shown you what the wiki can do. Next, we show you what it cannot, yet. The series spine is built, now we test its edges. Episode 7, Limits and Open Problems. See you there.